All right, open up your book to section 11-5. We're on page 585 in your book. The title of this section is Parametric Equations for Moving Objects. And the objective here is given a geometric description of the path followed by a moving object. Write the parametric equations to describe the path and plot it on your grapher. So we're going to go back to working with parametric equations here in this section and kind of deviate, I guess, a little bit from what we've seen so far in this chapter, which has been on polar equations. But we'll see that we can use the ideas we've learned about polar to help us come up with some of these equations. And if you recall parametric equations, you have both an x and a y equation that you're writing. X is equal to something in terms of a parameter t, and y is equal to something in terms of a parameter t. And so the nice thing about working with parametric equations for these, because they're split into an x and a y, I can focus on what's happening horizontally and then what's happening vertically, and I can write those in their separate parts there, the x part and the y part. All right, so let's take a look at an example here. Example 1 there on page 585. It says, suppose that you have a ship that moves with an eastward velocity of 21 kilometers per hour. It has a northward velocity of 13 kilometers per hour. Notice, by the way, those are split into a horizontal and a vertical direction for me. At time t equals 0 hours, the ship is at a point p of sub 0 as negative 43, 19, where the distances are in kilometers from a given lighthouse. All right, so the lighthouse is at the origin, is what we're seeing there in their sketch. All right, so for part A, it says write parametric equations for the ship's path using t in hours as the parameter. So to write the equation of this, we can kind of go from the sketch they've given us there to write an equation. And since it's moving at a constant rate, both horizontally and vertically there, that is both north, south, and east, west, we can just simply write linear equations to represent these two parts here. I'm going to do this part over here on the side here. So for part A, for x is equal to its starting point, which the starting point for x is equal to a negative 43. And then I have to add on a constant amount that I move by each hour. And in terms of the x direction, you're moving at 21 kilometers per hour. So it's 21 kilometers per hour times the amount of time that's passed. That would be t. So when t is equal to 0, for example, I'd get 43 kilometers. That's my starting point. If t is equal to 1, I'd add 21 kilometers on that to end up at a negative 22. That's my position after 1 hour, and so forth. And I can do the same thing for y now. Y would be equal to its starting position, which is 19, plus the amount it's going to change by each hour, which I'm moving north by 13 kilometers each hour. So I'll add on 13 times t. Again, if t is equal to 0 there, notice that 19 plus the 13 times 0 will give me 19 kilometers as my starting point. If I add on 1 hour later, that'd be 19 plus 13 times 1, that's 32 kilometers is where I'd be in terms of my location north and south from this lighthouse. So these two equations together are going to give me the parametric equation modeling this ship's movement. So that's part A. Part B says confirm that your equations are correct by plotting them on your grapher. So let's grab our calculator and let's plug these two equations into our calculator. All right, so with our calculator, let's switch over to parametric mode if you're not already in parametric mode. So that's under your mode menu. I'm already in polar mode here from our last activities we were doing. So let me switch over to parametric. And then when you go to your y equals menu, in your y equals menu, you need to put two equations in there. That's the two equations that we just came up with. So for your x, that's a negative 43 plus the 21 times t. And for your y's, that's the 19 plus the 13 times t is the two equations that we just came up with. Now they want me to sketch this. They didn't tell me amount of time here to let elapse here, but maybe I'll let this go for, say, 12 hours. Maybe we'll say half a day here. So under our window, let's set that up. For our t values, let's go from 0 to 12. So that's our 12 hours, half a day, I guess is what we're saying there. For your t step, you want to pick this to be a small enough number so that I get enough points plotted so I get an accurate sketch, although this is going to be linear here. So even if I don't pick a small enough t-step, I'll still get an accurate sketch of this. But let's set this to 0.1. If I set it to 0.1, then when I take, that interval from 0 to 12 and divide it into 0.1 steps, you're going to have, what, 120, actually 121 points that it's going to plot in order to sketch this thing. If I just take the quotient of those two, that tells me that. And then for my window, now for my X-min to X-max, my X-min, I have a good idea of where I should set that to because I know my starting point, and I'm headed east. So I can start out, say, -50. I'm starting at -43 is the starting point, so -50 is a little bit to the left of that. If I let this go for 12 hours, well, that's going to be 240 some kilometers. I'm going to move to the east here. So let's just go out to 300 then. That should be pretty close to me seeing everything on the screen. Actually, probably a scale of 25 here would be a good here for us. And for the y values, again, they tell me the starting point. I'm at y equals 19. Actually, I want to see the x-axis in here. So let's start out at 0 so I see that. And then again, I'm moving north 13 kilometers per hour. I'm letting that go for 13 hours. So, or 12 hours, so 13 times 12, that gives us 150 something. So adding the 25, let's go up to 200 here. I'm just kind of approximating some values here in my head to come up with what would be a decent window for this. And I can probably do a scale of, well, 25 would be fine here actually as well. You could probably make it a little smaller, would be fine too, but let's go with that. So there's my window. Let's go ahead and graph this, and hopefully we can see the path of this ship. There we go. We can see the starting point all the way over on the left side of our screen, and I can see its ending point. I guess I went a little further to the right with my window than I needed to, but that's all right. I get to see a good sketch of what this thing looks like here. Let me grab a picture of that, and we'll paste that in here. That's our sketch. That's part B of this, actually, and we'll label it that way here. So here's part B, our sketch of this. All right. All right. And finally, for part C, it says predict the time when the ship will be 60 kilometers north of the lighthouse. And then how far east or west of the lighthouse will that be? Well, if we want to be 60 kilometers north of the lighthouse, I'll just go back to this original sketch. Let's say that somewhere up here is about 60 kilometers. We'll say that's the 60. What we're trying to do is find out, where is this location right here? Where are we at? Now, my sketch I drew here, I guess assuming that it's going to be to the east of the lighthouse. I don't know if that's actually where 60 is at, but that's kind of what we're trying to do. So really what I need to do is I need to focus on the north-south direction. That's the y direction. I only have to worry about the equation for y right now in order to answer the question of when do I get to that point. So for part C, I'm going to take the y equation and set it equal to 60. So for part C, I'm going to say 60 is equal to, what was our equation? It was 19 plus 13t. And I want to solve this equation for t. That will tell me how much time it's going to take for me to be 60 kilometers north of the lighthouse. So we can do that. Subtract 19, so what does that leave us? 41 is equal to 13t. And so divide by 13, I'm going to write that as t is equal to 41 over 13. And I'm not sure what that's equal to, but let's punch that in our calculator here and find out what that's approximately equal to. All right, so on your calculator, we can just do that calculation here. We just need to take the 41 and divide it by the 13, and that should tell us at what time that occurs. So about 3.15, I guess 4 is what I'll approximate that as, 3.154. We'll write that down. So this is 3.154 hours is what this was measured in. All right. That's at what time? It'll take me just over 3 hours to get 60 miles north of the lighthouse. I'm starting kilometers north of the lighthouse. I'm starting about 19 kilometers north, and it takes me another 3 hours just over that to hit the 60 kilometer mark. Now the second part of that question said not only predict that, but then how far east or west of the lighthouse will you be at this time? So now east or west, that's my horizontal direction. That's my x direction. What I need to do is take that value of t and plug it into my equation for x. So let's do that. So I have x is equal to, your equation for x was negative 43 plus the, what was it, 21? Yeah, 21 times our value of t that we just came up with here. I'm going to write it as 41 over 13. And the question is, when does that occur? All right, well, let's punch that into our calculator and find out what we end up with. All right, so on your calculator, let's calculate that. We had a negative 43 plus the 21. And I guess I can use the previous calculation there if you want to, or I wrote it down as 41 over 13, so I'll just type it in that way. And what do we end up with? 23.231. In fact, let me just go ahead and grab a screen of that. And since it's got both these calculations, we'll just paste it in here. I'll show both of those calculations for me. And we can jot that down as well then. So turns out that x is equal to 23.231, and this is in kilometers. Now, since that's a positive value, that means we're now past the y-axis there. That means my sketch was pretty accurate then. I'm 23 kilometers to the east of the lighthouse. In fact, I'm going to write that. It's 23.231 kilometers east of the lighthouse.